Hello and welcome to this YouTube video about unsaturated hydrocarbons, specifically alkenes. Unsaturated hydrocarbons are organic compounds that contain double or triple bonds between carbon atoms. In this video, we will be focusing specifically on alkenes and exploring molecular formulas, structural formulas, condensed formulas, and IUPAC names of some alkenes. And also I am going to explain sp2 hybridization and formation of ethene or ethylene molecule. Later, IUPAC names of some structures will be explained. In the next video, we will be focusing on alkynes, another type of unsaturated hydrocarbons. So be sure to tune in to continue your exploration of unsaturated hydrocarbons. Now let us see what are alkenes. Alkenes are unsaturated hydrocarbons containing at least one carbon-carbon double bond. Alkenes are also called olefins, that is oil forming, because the lower members of alkenes form oily products when they are treated with chlorine or bromine. Alkenes form a homologous series having the general formula CnH2n. Compared to alkanes, two hydrogen atoms are less in alkenes. So the general formula of alkenes is CnH2n. Here N is the number of carbon atoms. Now let us see the homologous series of some alkenes. Here you know the general formula of alkenes is CnH2n, where N is the number of carbon atoms. So see here, we are going to see the molecular formulas, condensed formulas, structural formulas, trivial names and IUPAC names of some alkenes here. The first stable member of alkene series is C2H4. When you substitute N for 2 in this formula, we get C2H4, and this one is the first member of alkene series and known as ethylene, common name, and ethene, IUPAC name. And this one is the condensed formula of this molecule, C2H4 molecule, and here is the structural formula. And in alkenes there must be at least one double bond between the two carbon atoms. The trivial name of this molecule is ethylene. IUPAC name is ethene. The next member of this alkene series is C3H6. So there is CH2 difference between these two molecular formulas. That's why they are forming homologous series. So in this formula, one carbon and two hydrogen atoms are more compared to this formula, and this one is the condensed formula, and the structural formula is this, and the trivial name of this molecule is propylene. IUPAC name is propene. Okay. When N equal to 4, we get C4H8. That is, the molecular formula is C4H8. The condensed formula is this, and here double bond is there between these two carbon atoms, and we can put the double bond anywhere between the two carbon atoms. Depending upon the position of the double bond, the IUPAC name of that compound is named. So we are going to discuss the IUPAC names later. So here the structural formula is this, and the trivial name of this molecule is butylene. IUPAC name is butene. The next alkene in this series is C5H10. When N is equal to 5, C5H10 we get here. So this is the condensed formula of this molecule, and here is the structural formula. The trivial name of this molecule is pentylene, and the IUPAC name is pentene. Like this we get alkene series. So the first stable member, that is the alkene series, starts with C2H4. This one is the first stable member in the alkene series. Okay, so when N is equal to 2, we get ethene. When N is equal to 3, we get propene. When N is equal to 4, we get butene. Like this, pentene, hexene, heptene, octene. So like this we get alkenes. So here alkenes are forming homologous series because if you take any two consecutive molecular formulas, we find CH2 difference between them. Okay. Now let us explore the formation of ethene or ethylene molecule and sp2 hybridization. The molecular formula of ethene or ethylene is C2H4, and this one is the condensed formula CH2 double bond CH2. There is a double bond between the two carbon atoms in ethene molecule. Let us see how ethene molecule is formed. The atomic number of carbon, it is 6. The electronic configuration of carbon atom in the ground state is 1s2, 2s2, 2p2. Okay, you can see the ground state electronic configuration. In 1s there are 2 electrons, and in 2s also there are 2 electrons, and 2p orbital we have 3 2p orbitals, 2px, 2py and 2pz. These 3 are the equi-energy orbitals. Okay, and the 5th electron enters into 2px, 6th one enters into 2py. So there are 2 unpaired electrons in 2p orbital. This is the ground state electronic configuration of carbon atom. The electronic configuration of a carbon atom in the excited state is 1s2, 2s2, 2p3. So see what happens here. This one is the ground state configuration. So in the excited state, one of the electrons in 2s orbital jumps and occupies the empty 2pz orbital. See here. Now this one is the excited state electronic configuration of the carbon atom, and we have 4 unpaired electrons in carbon atom in its outermost orbit. Okay, so the second orbit is the outermost orbit, and there are 4 unpaired electrons in the outermost orbit in the excited state. The outermost electronic configuration of carbon atom in the excited state is 2s1 2p3. So here you can see the arrangement of these orbitals according to their energy. Okay, so here the energy of 2s orbital is lesser than the energy of these three 2p orbitals. So in C2H4 molecule, all CH bonds should not be identical. They should be different actually. But it was found that all CH bonds in C2H4 molecule are identical. In order to explain that, a concept called hybridization is suggested. In the formation of CH2 double bond CH2, that is ethene molecule, each carbon atom in its excited state undergoes sp2 hybridization by intermixing of one s orbital and two p orbitals and reshuffling to form three sp2 orbitals. So you can see here, before formation of the bonds, the central atom carbon in the excited state undergoes sp2 hybridization. That is, there is an intermixing of 2s, 2px and 2py orbitals and redistribute into three identical orbitals called sp2 hybrid orbitals. Okay, so after intermixing these three orbitals, one s orbital and two p orbitals, and they reshuffling into three identical hybrid orbitals, sp2 hybrid orbitals, and there is one unhybrid orbital, that is 2pz orbital, and each sp2 orbital contains one unpaired electron, and there is one more unpaired electron in 2pz orbital. Here you can better understand the hybridization process. You can see here, this is the nucleus of the carbon atom. This one is the 2px orbital. This one is the 2py orbital. You know the shape of p orbitals is dumbbell shape. And this one is the 2pz orbitals. These three orbitals are mutually perpendicular to one another. The angle between any two p orbitals is 90 degrees. Okay, so this one is the 2s orbital. Okay, so here I have shown only the outermost orbitals. So in 2s there is an unpaired electron, 2px, 2py, 2pz. So these are the four unpaired electrons in each orbital. So here, during the hybridization process, 2s orbital, 2px, 2py, these three orbitals intermix and redistribute into three identical orbitals. See here, 2s orbital plus 2px orbital and 2py orbital. So these three orbitals will intermix and reshuffling to form three identical orbitals. See here, they are mixing and forming three identical orbitals, sp2, sp2, sp2. Why? Because one s orbital and two p orbitals have been intermixed and reshuffled to three sp2 hybrid orbitals, and each sp2 hybrid orbital contains one unpaired electron. Okay, so if you measure the angle between any two sp2 orbitals, they get separated by 120 degrees around the nucleus of carbon atom. You see here, if you measure the angle between any two sp2 orbitals, here it is 120 degrees, and measure the angle between these two, here also 120, and here also 120 degrees. That is, any two sp2 orbitals are get separated by 120 degrees around the nucleus of carbon atom, and each sp2 orbital gets one electron, and there is one orbital in carbon atom which hasn't participated in hybridization, that is 2pz orbital. So this is the hybridization process. So after carbon undergoes hybridization, there are three sp2 hybrid orbitals containing one unpaired electron in each orbital, and there is one unhybridized orbital called 2pz orbital, and that also contain one unpaired electron. Okay, here you can see the formation of bonds by overlapping of orbitals. When carbon atom is ready to form bonds, one sp2 orbital of one carbon atom overlaps end to end with the sp2 orbital of other carbon atom to form sp2 sigma bond. So this is the first carbon atom, you can see here, and here is the nucleus of the carbon atom. Four orbitals are there here, three sp2 hybrid orbitals and one 2pz unhybridized orbital. Each of them contains one unpaired electron. Okay, here is another carbon atom. In this also three sp2 hybrid orbitals are there containing one unpaired electron in each, and there is one unhybridized orbital called 2pz orbital containing one unpaired electron. So here the sp2 orbital of this carbon atom will overlap with the sp2 orbital of this carbon atom. End to end overlapping will take place here and forms one sigma bond between the two carbon atoms. See here how they are overlapping. So here these two sp2 orbitals have been overlapped and formed sigma sp2 bond. Okay, next, the remaining two sp2 orbitals of each carbon atom get overlapped by s orbitals of two hydrogen atoms containing unpaired electrons. See here, one sp2 orbital has formed bond, and the remaining two sp2 orbitals, these two sp2 orbitals overlap with two s orbitals of two hydrogen atoms. See here, this is one hydrogen atom, this is 1s orbital of hydrogen atom, and 1s orbital of this hydrogen atom overlaps end to end with sp2 orbital and forms one sigma bond. Okay, here I am representing the bonds simultaneously, and here also one more hydrogen, and this is the 1s orbital of this hydrogen atom. It overlaps end to end with sp2 orbital and forms one more sigma bond here. Here also one hydrogen atom overlapping with sp2 orbital forming sigma bond. Here also one hydrogen atom, that is 1s orbital of hydrogen atom, is overlapping with sp2 orbital and forming one sigma sp2s bond. So like this, bonds have been formed. And there are two unhybridized pz orbitals here. In each carbon atom, there is one 2pz orbital which is not hybridized. And these two unhybridized 2pz orbitals will overlap laterally and forms pi bond. See here, the unpaired 2pz orbitals on the two carbon atoms overlap laterally and form a pi bond. See here, these two lobes will overlap sideways and forms a pi bond. You can see how they are overlapping, sideways overlapping of these two pz orbitals, okay, and forms pi bond. So it is due to the lateral overlapping of the orbitals, pi bond is formed. So here pi bond has been formed between the two carbon atoms. Okay, C2H4 molecule, and here you can see that means there exists a sigma bond and a pi bond between two carbon atoms in ethene molecule. And in this molecule, all CH bonds are identical. Okay. Nomenclature of alkenes IUPAC system. Here are the rules for naming alkenes in IUPAC system. The name is obtained by dropping the suffix ane from the name of the corresponding alkane and adding the suffix ene. That means we have to remove the last three letters from alkane and add ene after removing ane. That means alkane minus ane plus ene, we get alkene. That is alk plus ene, alkene. The longest chain of carbon atoms containing the double bond is selected. Numbering of the chain is done from the end which is nearer to the double bond. When there are two or three double bonds in the molecule, the ending ane of the corresponding alkane is replaced by adiene or atriene. That is, when two double bonds are there, it is alkadiene. When three double bonds are there, it is alkatriene, like this. It may be remembered that first member of alkene series is CH2, replacing N by 1 in CnH2n, known as methene, but has a very short life. The first stable member of alkene series is C2H4, known as ethylene, common name, ethene, IUPAC name. Okay. Let us see some examples here. IUPAC names of a few members of alkenes. Here is the problem number 1. Write the IUPAC name of the following structure. This is the structural formula of one alkene, and we have to provide the IUPAC name for this structure. The number that locates the position of the substituent, here double bond, is known as locant. So double bonds are also considered as substituents. So The number that locates the position, that is, to which carbon atom double bond is attached, that is known as locant. Lowest locant rule. The carbon atoms carrying the first substituent double bond get the lowest possible number. That means wherever the double bond is there, at which carbon atom double bond is there, we have to give the lowest number to that carbon atom while numbering the chain. So here you can see this is the given structure, CH3 bond CH2 bond CH2 double bond CH2. So here we can number carbon atoms in this chain either from left to right or from right to left. Left to right, and the position of the locant is 3. If numbering is done from left to right, double bond is there at third carbon atom. Suppose if the numbering is done from the right to left, the first carbon carries the substituent or double bond. So the carbon atoms carrying the first substituent, that is double bond, get the lowest possible number while numbering the carbon atoms in the chain. So we have to select the numbering from right to left. So this is wrong numbering. This one is correct numbering. If numbering is done from left to right, on the third carbon atom double bond is there. If the numbering is done from the right to left, on the first carbon itself double bond is there. So the double bond should get the lowest possible number while numbering the carbon atoms in the chain. So this one is correct. Next, root word. After numbering the carbon atoms in the chain, we have to select the root word. What is the root word? In this chain, how many carbon atoms are there? So here, these are the root words, number of carbon atoms in the chain, and how many carbon atoms are there in it? There are 4 carbon atoms. So the root word is but. Next, primary suffix. See here, the primary suffix here indicates the nature of saturation. If double bonds are there, it is En. Okay. If single bonds are there, it is En. En. If triple bonds are there, it is Yn. E. Ein. En. In. Ein. So in this double bond is there. For that reason, the primary suffix is En. Next, secondary suffix. Here the double bond is also treated as a functional group, and in this chain there are no other functional groups and only hydrocarbons are there in this chain. For that reason, the functional group, the secondary suffix is E. So when CH functional group is there, that is only hydrocarbons are there, the secondary suffix is E. Okay. Now we have to write the IUPAC name for this structure. But, and double bond is there on the first carbon. Okay. The first carbon is carrying the double bond. So but 1 ENE. But 1 in. Here is the problem number 2. Write the IUPAC name of the following structure. This is the structure we are going to name. CH3 bond CH double bond CH bond CH2, and we have to select the longest chain. This is the only chain containing the double bond. After selecting the longest chain, here we have to give the numbering to the carbon atoms in such a way that the carbon atoms containing the substituent ends should get the least number. So here we can give the numbering to the carbon atoms either from the left to right or from the right to left. Let us see here, I am giving left to right. So the second carbon is carrying double bond if the numbering is done from left to right. Suppose if the numbering is done from right to left, same 1, 2, 3, 4. Again, the second carbon contains double bond. Okay, so in this case, you can give numbering in either side, from left side or from right side. Then what is the root word? In this, how many carbon atoms are there in this chain? 4 carbon atoms are there. When 4 carbon atoms are there in the chain, the root word is but, and primary suffix, the saturation, nature of saturation, because the chain contains double bond, so it is primary suffix is en, secondary suffix is, this chain contains only hydrocarbons. So the functional group only CH hydrocarbons are there. For that reason, the secondary suffix is E. Okay, so the IUPAC name of this structure is, on the second carbon we have the double bond. So but-2-ene. Next, third problem, write the IUPAC name of the following structure. CH3, CH2, CH2, CH, CH2. And here is the answer. This is the given structure, and after selecting the longest chain containing the double bond, we should give the numbering to the carbon atoms in the chain. So numbering can be given either from left to right or from right to left, but we have to keep one thing in mind, that the locant, that is the double bond containing the carbon atom, should be given least possible number. So if the numbering is done from left to right, fourth carbon containing the double bond. If the numbering is done from right to left, first carbon is carrying the double bond. So numbering from left to right is wrong numbering, and right to left is the correct numbering. So what is the root word here? You can see how many carbon atoms are there in this chain. 5 are there. When 5 carbon atoms are there, it is pent. Next, primary suffix, here double bond is there, so En. Secondary suffix, only hydrocarbons are there in this chain, in this structure, so it is secondary suffix is E. So the IUPAC name of this structure is pent-1-ene. Pent-1-ene. Okay. Here is the problem number 4. Write the IUPAC name of the following structure. CH2 double bond, CH bond, CH double bond, CH2. So in this organic structure, 2 double bonds are there. Now, lowest sum rule we have to follow. When many substituent ends, that is double bonds, are present, the numbering is done from the end whereupon the sum of locants is the lowest. I already told you what is locant. Locant is a number actually. The number that locates the position of double bond is called locant. Okay, so here CH2, CH CH, CH2, and we can give the numbering either from left to right or from right to left. Let us see here, I am giving numbering from left to right. In this, two double bonds are there, and right to left. And we have to follow the lowest sum rule. That means we have to add up the locants. Locants means numbers. That is, numbers of the carbon atoms containing the double bonds. From left to right, see here, first carbon is carrying double bond and third carbon is carrying double bond. So 1 plus 3 is equal to 4. In case of right to left numbering, let us see here, 1 plus 3 equal to 4. Here also, first carbon, third carbon containing double bonds. Okay, so you can give the numbering in either way. No problem in this case. So root word is 4 carbon atoms are there. It is but. And the more important thing is that when there are two double bonds in the molecule, the IUPAC name is alk plus adiene, that is alkadiene. So we have to attach A to the root words when more than one double bond is there. So here two double bonds are there. For that reason it is add A, alka, so buta. Okay, next primary suffix is, because the chain contains only double bonds, it is En. Secondary suffix, only hydrocarbons are there, it is E. So first carbon and the third carbons are carrying double bonds. So here the substituent or double bonds are repeating. So we have to use the numerical designations and numbers also while naming this structure. So the IUPAC name is buta 1,3-diene. Buta 1,3. These are the numbers and di is the numerical designation. So buta 1,3-diene. Let us see one more example here. Write the IUPAC name of the following structure. This one is a structure and we are going to name this structure. This is the given structure. Let us give the numbering from both sides. 1, 2, 3, 4, 5, 6, 7. Right to left, 1, 2, 3, 4, 5, 6, 7. Okay. So let us check which one is the correct way of giving the numbering, because we have to follow the lowest sum rule. Left to right. On the second carbon, double bond is there. On the fourth carbon, double bond is there. So the sum of the locants, that is 2 plus 4 equal to 6 if the numbering is done from left to right. And let us check right to left. On the third carbon, double bond is there, plus on the fifth carbon, double bond is there. 3 plus 5, we get 8. So this one is the correct. According to lowest sum rule, the numbering is done from the end whereupon the sum of locants is the lowest. Okay, so this one is the wrong numbering and this one the correct numbering. Okay, next, root word. How many carbon atoms are there? 7 carbon atoms are there. The root word is, here you see once again, 2 double bonds are there. It is alkadiene. That means we have to add A to the root words. So 7 are there. Hepta. Hept plus A. Alka. not alk, alka. So hepta, and primary suffix saturation is there, that is nature of saturation is double bond is there en, so primary suffix is en, secondary suffix is e, and here we are using numbers, that means to which carbon atoms double bonds are attached. Next, and we are using even numerical designations, that is if the same substituent is repeated twice, we have to use di as the numerical designation. If 3 times it is repeating, we have to use tri as the numerical designation, like this. So the name of this organic compound alkene is hepta. On the second carbon and on the fourth carbon double bonds are there, and 2 double bonds are there, for that reason it is diene. 2, 4, these are called numbers, di is called numerical designation. Okay, so this is the name of this organic compound. Next problem, write the IUPAC name of the following structures. Here is the structure of an organic compound. We have to give the IUPAC name for it. So you can see in this structure only double bonds are there as substituents. Okay, that is suffixes, and I'm not attaching any other functional group like aldehydes, CHO, alcohols, OH. They will be attached and discussed later coming videos, in the next coming videos. So let us name it. We have to follow the lowest sum rule again. When many substituents are present, that is in this case double bonds are present, the numbering is done from the end whereupon the sum of locants is the lowest. Sum of locants means sum of the numbers containing the double bonds. So here this is the given structure. Let us do the numbering from left to right. Total 8 carbon atoms are there, and 3 double bonds are there in this structure, and numbering from right to left I am giving, and we have to choose one of them. From left to right, if numbering is given from left to right, on the first carbon double bond is there, 1 plus, fourth carbon contains double bond, and sixth carbon is containing double bond. Totally 1 plus 4 plus 6, that is sum of the locants is 11. From right to left, you see here second carbon, that is 2 plus, fourth carbon is containing double bond 4 plus, and seventh carbon is containing double bond 7. So sum of the locants is 2 plus 4 plus 7, 13. So right to left, giving the numberings from right to left is wrong. Giving the numbering from right to left is wrong. Wrong numbering, correct numbering. Now root word, how many carbon atoms are there in it? 8. So you have to use. In these 3 double bonds are there, the IUPAC name of alkenes containing 3 double bonds is alk plus A-triene, that is alka-triene. So we have to add A to these root words. So octa. Next, primary suffix is double bonds are there, so En. Secondary suffix is only hydrocarbons are there in this chain, so it is E. Okay. Now octa. Okay. 1, 4, 6 triene. octa-1,4,6-triene. And here is the another problem. Write the IUPAC name of the following structure. You can see here. Lowest sum rule. When many substituents are there, that is double bonds are there, the numbering is done from the end whereupon the sum of locants is the lowest. This is the given structure. Numbering is being done from left to right, from right to left also. Let us check which one is the correct one. We have to add up all the locants. So if numbering is done from left to right, 2 plus 4 plus 6, 12. From right to left, 2 plus 4 plus 6, 12. So both are correct. Both are correct here. So root word is octa. Next, primary suffix is en. Secondary suffix is e. So IUPAC name is octa 2, 4, 6 triene, because 3 double bonds are there. So octa is the root word, 2, 4, 6 are the numbers, tri is the numerical designation, en is the primary suffix, and last e is the secondary suffix. Okay. Thank you.